So there is a proposal about that methodology in order to assess whether it's been successful or not. So the signals are sent first to a computer that stores the information, and all that is sent to the robot. The robot that registers everything, and there is an automatic report that is generated. So we capture all the information, the EMG signal, and the slope angle, or the tilting angle. And with all of these, we can find out what movements the child is doing. And once we store all this information, we send it to Robotics, and he decides the robot executes the movements. Also, at the same time, a camera will record the child's face, because it's a way of assessing if there is learning, if the child is happy or not. We do not know it, but we believe that if we see a smile or an expression of happiness, then that means that the child managed to do what he wanted to do. And, well, this is the system that we used. Here you can see the robot with the thumb, the pen that's on the thumb that is going to draw on a white paper. The electrodes that are used are a bipolar electrode, and the board that we've developed, and that captures the information regarding inclination, slope, and regarding the movement, the EMG signal. So we calculate the 3 axes. We captured the signs of inclination from many tests. We also receive information about the battery level, whether the battery needs to be charged or not, etc. So in the end, once we've created the movement coordinates, we can see whether the robot moves. And for instance, we put a pen so that the child can draw anything. So in that case, we will have to move the robot over a white piece of paper that's on the floor, and then we start drawing. This is the board. We use communication via Bluetooth. This is all technical data. Here's the camera that records the face of the child, also wireless. The computer, we use Windows XP. In this case, it was enough to use Windows XP, and we've developed the interface. The interface, well, at the beginning, the child doesn't start straight away to use the robot. The first thing we do is that there is a virtual environment where there is a yellow ball that it represents the robot, and the child has to play and move the ball, just so that the child is aware that he can move. They can work with a movement, for instance, just like putting his head down. If the ball goes forward, if he faces right, the ball moves to the right. To the left, it moves to the left. And if it goes back, if he moves the head back, it stops. And the quicker you move the head, the quicker the ball will move. That is if the user is moving the head. If it's the arm that the user uses, then it's a more intuitive movement. And the child will receive the feedback from the movement of the ball. This is a video of what we did. I'm not sure if you can see it. It's all green, isn't it? There must be a problem with the driver. Well, the idea was just to show here the environment. This is a virtual environment. We have a ball that should be yellow here, the face of the child. In this case, it was a student that worked with us. But normally we record the child face, and everything that is captured is recorded in the computer for for its evaluation afterwards. So it's possible to do all of this, but once the child makes the movements, well, he practices first, like I said, and at the end, it's considered suitable to be part of it. We've done several tests with different children, but not all of them could interact with the virtual robot, and this was a big problem because when we make an appointment with the carers or the parents, they come with certain expectations that this is going to work, and when they see that the kid doesn't respond, then of course there is a lot of frustration, and this is very difficult. So it's difficult for us as engineers to see the frustration of the parents because they think that maybe the problem of their child will be solved. But anyway, after using it, here you can see some examples of application of the robot drawing. You can draw on white paper with the thongs, holding on to that pen. And you can say, well, and what is that drawing? Well, it's what the kids wanted to draw. That's what it's important to make. It shows that it is possible. And the child is moving. You can see it is moving the sensor, and you can see the robot responding. As you can see here. Here he's holding on to the sensor. Can you see the movement, the contraction movement, in order to raise the pen and put it down? That's the contraction and distension movement. So this is a simulation of what the child will do. So once this is been demonstrated that this is possible, then we start the work with the children. And we've done a few tasks with them. I'm going to show some on the video. This is... Can you see that the robot has changed? We have put a clown on top of the robot so that it's more attractive for the children.